This is SpaceTime Series 27, Episode 18, for broadcast on the 9th of February 2024. Coming up on SpaceTime, claims that lopsided galaxies could shed new light on dark matter. Virgin Galactic undertakes its first space tourism flight for 2024. And we look back at the ill-fated Sunrise 3 mission, which was launching the biggest telescope ever to fly on a balloon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that lopsided galaxies are providing astronomers with new clues about a mysterious invisible substance called dark matter. Scientists have no idea what dark matter is, but we can see its gravitational influence on normal, so-called baryonic matter, the stuff stars, planets, houses, people, trees, dogs, cats and cars are made out of. Dark matter appears to hold galaxies together. It stops them flinging apart as they rotate. And there's a lot of it. It makes up at least 3/4 of all the matter in the universe. And that's really disconcerting if you're a scientist. It means that you know nothing about the majority of the stuff that makes up the universe. The new study suggests that astronomers can measure properties of dark matter by the so-called proper motion of galaxies across space. The prerequisite is to find a galaxy in the universe that moves relative to dark matter. Now, since everything in the universe is in motion, and since there's a great deal of dark matter in the universe, it's not really difficult to find these galaxies. Heavy objects like galaxies attract all types of matter, whether it's dark matter or the more visible matter that we encounter on a daily basis. Now, we know dark matter interacts only gravitationally with normal matter. So, as dark matter moves past the galaxy begins to pull the dark matter particles towards it. However, the change of the speed direction of the particle takes time. And before the trajectory curves towards the galaxy, they're already managing to pass the galaxy. So the dark matter particles aren't entering the galaxy, instead they're moving behind the galaxy. Therefore, the density of matter back there increases. And this should lead to a slowdown of the galaxy, a phenomenon known as dynamical friction. Now, the strength of dynamical friction, in turn, depends on how quickly dark matter particles pass the galaxy. That is, how long the galaxy has time to change the trajectory of the dark matter particles. When the particles are passing slowly, the density of matter increases closer to the galaxy, causing it to slow down more. As the dark matter particles move past the galaxy, the gravity field of the galaxy affects the particles of matter, creating an overdensity behind the galaxy. Now, this overdensity slows down the galaxy and distorts its shape, and that could be a clue to dark matter. Now, finding these lopsided galaxies isn't difficult because they make up about 30% of all the galaxies in the universe, so there are lots of them out there. Trouble is, the lopsided shape of the galaxy isn't always caused by dynamical friction. Other factors include galaxies that were formed asymmetrically through galactic cannibalism or mergers. However, astronomers can usually detect the difference because of the existence of the remains of the other galaxy's nucleus or because of a larger stellar halo. Now, galactic lopsidedness can also be caused by a constant inflow of gas. So, to measure the velocities of dark matter, astronomers really need a lopsided galaxy that is as isolated from other galaxies as possible. Only then could you be sure that nothing's happened to it over a long period of time other than the passage of dark matter. This is SpaceTime. Still to come, Virgin Galactic's first near-space flight for 2024, and we look back at the ill-fated Sunrise 3 mission. All that and more still to come on SpaceTime. Virgin Galactic's undertaken a successful first flight for the new year, with its rocket-powered spaceplane carrying 4 space tourists to the edge of space from its New Mexico spaceport. The Galactic 06 mission reached an apogee or maximum altitude of 88.83 kilometers. Now, that's still well short of the 100-kilometre high Kármán line, which marks the internationally recognised start of space, but it's about as high as the Spaceship Twos seem to be able to fly. After being released from its twin fuselage mothership, the VMS Eve, high above the New Mexico desert, the blue and white delta-winged rocket plane VSS Unity quickly fired up its hybrid rocket engine and accelerated vertically, reaching Mach 2.98 as it climbed to the edge of space. After reaching apogee and allowing passengers to experience several minutes of weightlessness, Unity began its re-entry glide back down to Earth, eventually landing on the same runway from which it had taken off 56 minutes earlier, attached to its Eve mothership. Meanwhile, ongoing development is continuing on Virgin Galactic's next generation of Delta-class spaceplanes. They're expected to start test flights next year and enter service carrying passengers by 2026. Virgin Galactic says its next flight to the edge of space is expected to include a mix of both researchers and space tourists. We'll keep you informed. This is SpaceTime. Still to come, we look back at the Sunrise 3 mission to send the largest telescope ever mounted on a balloon into the stratosphere, and the spectacular constellation of Orion and the nearby massive ticking time bomb of Betelgeuse are among the highlights of the February night skies on Skywatch. Okay, let's take a break in our program for a word from our sponsor, Incogni. As you know, we take internet security very seriously, and Incogni is a guardian in the digital age. Have you ever worried about the extensive list of personal details about you and your family that are currently floating around online? Those concerns aren't unfounded. Take, for example, people's search sites. These are sites on the dark web that collect and display vast amounts of personal data from public records to social media, usually without consent. That data is then on-sold to bad guys who'll use it to try and exploit you and your family. This sort of exposure quickly leads to privacy breaches, identity theft, scams, unwanted personal contact. Like me, you've probably been inundated with spam emails and wondered where they got those details from. Well, people's search sites are probably to blame. And that's just one small example. And here's where Incogni steps in. Not only does Incogni advocate for your right to privacy by engaging data brokers to delete your personal information, it also tackles the risks associated with people's search sites. The process of manually trying to remove your data from these sites is daunting and never-ending as new records constantly emerge. In light of these concerns, Incogni emerges as your ally, working hard to ensure not just that your information is removed, but that it stays removed. And this continuous effort significantly lowers your chances of spams, scams, and identity theft. And right now, as a loyal SpaceTime listener, we're offering an exclusive 60% discount on Incogni subscriptions. So don't let your personal information become a commodity. Visit incogni.com/StuartGarrett to secure this exclusive offer and safeguard your privacy. Remember, that's Incogni, INCOGNI. And the URL again, incogni.com/StuartGarrett. And of course, we'll include the details in the show notes and on our website. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
Back in July 2022, the Max Planck Institute Sunrise 3 Solar Observatory high-altitude balloon-borne telescope made a premature landing just hours after its launch. The mission had been designed to carry the largest telescope ever launched on a balloon high into the stratosphere. A gondola loaded with scientific instruments was attached to a 6-metre-tall helium-filled balloon. The mission would observe the Sun from an altitude of 35 kilometres, where it's above more than 99% of the Earth's atmosphere. This would provide a clearer, less distorted image than possible from the ground, where different temperatures cause different layers of air to refract light differently. The atmosphere is so thin that air turbulence doesn't obscure the view, and the drier air at this altitude also allows a wider spectrum of wavelengths to reach the telescope compared to the fairly narrow band visible from the ground. Sunrise 3 was designed to undertake a multi-day flight, collecting unique measurements from a layer of the Sun more than 2,000 kilometres thick, extending from just below the Sun's visible surface, that's the photosphere, all the way to the upper chromosphere, a highly dynamic layer between the photosphere and the Sun's outer atmosphere, the corona. Even after decades of research, astronomers still find the Sun's chromosphere a mysterious region of the Sun's atmosphere. It experiences an enormous temperature jump from a comparatively moderate 6,000 degrees Celsius at the surface up to 200,000 degrees Celsius further up, and in the layers above this, the temperature rises to over 1,000,000 degrees Celsius. A multitude of processes that scientists still don't fully understand, that could involve a lot of magnetic reconnection, occur up in the chromosphere and supply the corona with energy. Now, in concert, these processes not only generate the incredibly high temperatures of the corona, but also facilitate violent eruptions in which the Sun repeatedly hurls particles and radiation into space in the solar wind. Sunrise 3 was equipped with a 1-metre telescope, the largest balloon-borne telescope ever launched, and its gondola carried 3 scientific instruments: an ultraviolet spectropolarimeter and imager, a visible light imaging polarization spectrometer, and a near-infrared polarization spectrometer. These allowed the mission to study the Sun in a wide range of wavelengths. The 3 instruments were fed by way of 2 support devices: an image stabilization and light distribution system which supplies the telescope's images to the scientific instruments, and a correlation tracker and wavefront sensor which monitors the vibration or image blur of the telescope in real time, compensating as needed to obtain the highest possible resolution images of the Sun. In the build-up to the mission's launch, technical and scientific teams from Germany, Spain, Japan and the United States prepared the complicated electronics and optical instruments of the mission and conducted a series of exhausting mission rehearsals. The team were greeted by driving snow and icy temperatures of down to minus 15 degrees Celsius when they arrived at the launch site at Sweden's Estrange Space Center near Kiruna, which isn't far from the Arctic Circle. Launching from the Arctic Circle involves a considerable logistical effort. But for the scientific success of the mission, the remote launch site in the far north was crucial. Since the Sun does not set beyond the Arctic Circle during the northern summer, Sunrise 2 could record observational data around the clock as it flew. After a series of delays due to logistical issues and bad weather, the 6-metre-tall balloon was eventually launched. However, soon after its launch, scientists found they were in trouble, unable to correctly aim the telescope towards the Sun. That made it impossible to obtain any observational data. And so, the mission was terminated, just hours after it began. The observatory landed safely on uninhabited Swedish territory, not far from the border with Norway. The only good news was that the scientific instrument package was left largely intact by the landing. This third ill-fated flight followed 2 highly successful earlier missions back in 2009 and 2013. It was a valiant effort, ultimately ending in failure. This report from the Max Planck Foundation.
Earth's atmosphere has always been a challenge for ground-based solar observation. Turbulence in the air obstructs our view, and ultraviolet light does not reach the Earth's surface. To fully utilize our fine-tuned instruments, we need to surmount almost all of our atmosphere and enter the stratosphere. We've built a telescope to direct sunlight into our instruments and a gondola to carry and guide them. We've integrated it all together to work as one and conducted extensive tests in preparation for its flight on a stratospheric balloon. Our goal is to better understand our star's capricious nature and its effects on Earth. However, it's not easy to investigate the Sun. The only information we get from the Sun is encoded in sunlight. That is why we engineer unique instruments that extract different information from sunlight. An important part of our preparations takes place in laboratories that are kept meticulously free from dirt and dust. Even the smallest dust particles on our instruments may have a negative impact on the quality of our data.
This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for February on Skywatch. February is the second month of the year in the Julian and Gregorian calendars. It's also the shortest month of the year, and the only one which is a length less than 30 days. The month is 28 days in common years and 29 in leap years, with a quadrennial 29th day being called a leap day. This additional day every fourth year is needed to keep the calendar year synchronized with the astronomical year. Because seasons and astronomical events don't repeat in whole numbers of days, calendars that have the same number of days in each year tend to drift over time with respect to the event the year is supposed to track. By inserting an additional day every fourth year, this drift can be corrected. The extra days occur in years which are multiples of 4, with the exception of years divisible by 100, but not by 400. Similarly, in the lunisolar Hebrew calendar Adar Aleph, a 13th month is added 7 times every 19 years to the 12 lunar months in its common years, in order to keep its calendar from also drifting through the seasons. And in the Baha'i calendar, a leap day is added whenever it's needed, in order to ensure that the following year begins on the vernal equinox. The length of a day is also occasionally changed by the insertion of leap seconds into Coordinated Universal Time, or UTC, more often referred to as GMT or Greenwich Mean Time. This is needed because of the variability in Earth's rotational period. But unlike leap days, leap seconds aren't introduced on a regular schedule, since the variability in the length of the day is not entirely predictable. Okay, let's turn our attention to the sky now. And throughout most of February, sky watchers in the southern hemisphere may be lucky enough to catch sight of the occasional meteor associated with the Alpha and Beta Centaurids meteor showers. Now, as their names suggest, they appear to radiate out from the direction of the constellation Centaurus as 2 separate streams, although they rarely produce more than 1 or 2 meteors per hour. They usually peak around February the 8th, and to see them at their best, you really should be looking towards the east a few hours before dawn. Okay, looking north now, and high in the sky is the famous constellation of Orion the Hunter. Orion is one of the best known and most recognized constellations in the sky. In Greek mythology, Orion was the son of a Gorgon and Poseidon, who was also known as Neptune, the god of the sea in Roman mythology. Orion was a mighty but egotistical and conceited hunter, who once boasted that his skill would allow him to kill all the world's animals. So the earth goddess Gaia sent Scorpius the scorpion to kill him and save the animals. Orion was stung in the shoulder, but then the healer Ophiuchus intervened to save him and crush the scorpion. Both Orion and the scorpion were then placed in the heavens to play out the story each year, with Scorpius rising in the east as the defeated Orion sets in the west. Now, a variation of this fable speaks of Orion getting a little bit too close to Artemis, the goddess of chastity. Now, her brother Apollo didn't approve of this relationship and tricked Artemis into testing her skill by shooting an arrow at a distant speck on the ocean. What Artemis didn't know was that that speck was actually Orion, swimming to escape the giant scorpion created to kill him. When Artemis discovered what she had done, she placed Orion's body in the sky as the stars we see today. Similar variations to this story appear in other cultures, including ancient Egypt, where Orion is known as Osiris, the god of the underworld and of regeneration. The very earliest depiction that's been linked to the constellation Orion is a prehistoric mammoth ivory carving found in a cave in the Arch Valley in West Germany in 1979. Archaeologists have estimated that it would have been fashioned somewhere between 32,000 and 38,000 years ago. The distinctive pattern of Orion has been recognized in numerous cultures around the world, including ancient Babylonian star catalogues dating back to the Late Bronze Age. Orion's easily identified by its rectangle of 4 stars, surrounding a central trio of stars in a row which form Orion's belt. And hanging from the belt are the stars which make up the Sword of Orion. To those of our listeners in the southern hemisphere, Orion appears to be upside down, with the sword on his belt pointing upwards. And if you look really carefully, you'll notice that the middle star in the sword looks a bit fuzzy. That's because it's not a star, but rather a huge star-forming region known as Messier 42 or M42, the Great Nebula in Orion. Located some 1,344 light-years away, M42 is the nearest large star-forming region to Earth, containing hundreds of newly forming stars and protostars. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. The Orion Nebula is more than 24 light years across, and it contains as much mass as 2,000 suns. It's one of the most scrutinised and photographed objects in the night sky, and is among the most intensely studied celestial features. The Orion Nebula has revealed much about the process of how stars and planetary systems are formed from collapsing molecular gas and dust clouds. By studying M42, astronomers have directly observed protoplanetary disks, brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of nearby massive stars in the nebula. The Orion Nebula contains a very young open cluster known as trapezium due to the asterism of its 4 primary stars. The trapezium itself is a component of the much larger Orion Nebula cluster, an association of around 2,800 stars within a diameter of just 20 light-years. The brightest star in the constellation of Orion is the semi-regular variable red supergiant Betelgeuse, which represents the scorpion's sting on Orion's shoulder. Currently known as Betelgeuse, and commonly referred to by the public as Betelgeuse, don't say it 3 times, the names are both tortured mispronunciations of the original Arabic name Ibtal-Yawza, meaning the hand of the big man being Orion the Hunter. Located some 643 light-years away, Betelgeuse is the 9th brightest star in the night sky. And it's big, really big. In fact, red giants like Betelgeuse are among the largest stars in the universe, at least in terms of volume, although they're by no means the most massive or luminous. Calculations of Betelgeuse's mass range from slightly under 10 to a little over 20 times that of the Sun, and it shines with some 100,000 times the Sun's brightness. If it were placed at the location of our Sun at the centre of our solar system, its visible surface would extend almost as far out as Jupiter, engulfing the orbits of the planets Mercury, Venus, Earth and Mars, as well as the main asteroid belt. Betelgeuse began its life around 10 million years ago as a spectral type O or B blue star. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in. Then there are spectral type K orange stars, and the coolest and least massive stars are spectral type M red stars, often referred to as red dwarfs. Each spectral classification system is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 being the coolest, and then Roman numerals added to represent luminosity. Put them all together, and our Sun is officially classified as a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are between 75 and 80 times the mass of Jupiter, or about 0.08 solar masses. Red supergiants are fascinating objects. After spending billions of years fusing hydrogen into helium in their core, a star's core hydrogen supply eventually runs out, and the balancing act between nuclear fusion pushing outwards and gravity pushing inwards stops, with gravity winning. The entire mass of the star then comes crashing down onto the core. This causes a dramatic increase in the core's pressure and consequently temperature. Things get hot enough to trigger what's called a helium flash. This causes the core helium, which has been created in the star, to begin fusing into carbon and oxygen. At the same time, the hydrogen-rich region around the stellar core has now moved down into that region where the temperatures and pressures are high enough for hydrogen fusion into helium to commence in a shell around the core. Now, as all this is going on, the increasing core temperature results in an increasing level of luminosity, and the resulting radiation pressure from the shell burning causes the outer diffuse gaseous envelope of the star to expand to hundreds of times its previous radius. And as the now bloated star's chromosphere or visible surface moves further away from its core, it cools down, turning redder. Hence the star has become a red giant. Small stars like the Sun eventually lose their outer envelopes completely, which continue expanding outwards as planetary nebula. This ultimately exposes the star's white-hot stellar core as a white dwarf, which is then left to slowly cool down over the eons of time. However, stars with masses more than around 8 times that of the Sun experience a very different fate. Unlike the Sun, their fusion cycle doesn't end with helium in the core fusing into carbon and oxygen. They have enough mass to fuse carbon and oxygen in their core into progressively heavier and heavier elements through a different process, while the shell burning around the core also fuses progressively heavier and heavier elements. Carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. These stars have become supergiants. Eventually they'll explode as core collapse supernovae, ending up as either super-dense strange objects called neutron stars, or even stranger objects called black holes. Singularities of infinite density and zero volume, where the laws of physics as science understands them no longer apply. It's too early to tell whether Betelgeuse's ultimate fate will be as a neutron star or black hole. As a red supergiant, Betelgeuse is reaching the end of its life, and it's expected to explode as a core collapse or Type II supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean a million years from now. When it does explode, Betelgeuse will temporarily outshine all the other stars in our galaxy, and it will be clearly visible in the daytime sky on Earth. The last star to be seen by humans to go supernova in our galaxy was Tycho's star. That was in 1572, and that was before the invention of the telescope. Diagonally opposite Betelgeuse, marking Orion's left foot, is the blue supergiant star Rigel, the second brightest star in the constellation Orion. Rigel is part of a triple or possibly quadruple star system with 3 or 4 small companion stars. The primary star, Rigel A, is located some 863 light-years away and has about 23 times the mass of the Sun. The star's already exhausted its core hydrogen supply, and it's swollen out to between 79 and 115 times the Sun's radius, and is somewhere between 120,000 and 279,000 times as luminous. Like Betelgeuse, it's now fusing progressively heavier and heavier elements in its core, meaning it too will soon go supernova. Rigel A pulsates quasi-periodically and is classified as an Alpha Cygni variable star. Alpha Cygni variables are variable blue or white supergiant stars which exhibit non-radial pulsations, meaning some areas of the star's surface are contracting while others are expanding. This causes irregular variations in brightness due to beating of multiple pulsation periods. The pulsations are likely caused by iron opacity variations and typically have periods ranging from several days to a few weeks. Rigel A's companion star Rigel B is some 500 times fainter than the supergiant, and it's only visible with a telescope. Rigel B itself is a spectroscopic binary system comprising 2 main sequence blue-white stars. Main sequence stars are those happily fusing hydrogen into helium in their core. And spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated, at least from our viewpoint on Earth, by their spectroscopic signatures. The 2 stars making up Rigel B are estimated to be 3.9 and 2.9 times the mass of the Sun, respectively. And one of those stars, Rigel BB, itself may be a binary. It appears to have a very close visual companion, Rigel C, of almost identical appearance. The third brightest star in Orion is Bellatrix, Orion's left shoulder. It's a spectral type B main sequence blue star with about 8.6 times the mass and 6 times the radius of the Sun. Bellatrix is located about 250 light-years away. It has an estimated age of approximately 25 million years. Now that's old enough for a star of this mass to have consumed much of the hydrogen in its core and begin the process of evolving away off the main sequence into a blue giant. One of the most stunning nebula in Orion is the spectacular Horsehead Nebula, Barnard 33. The Horsehead is a dark nebula located just south of the star Alnitak, which is the furthest east on Orion's belt, and is part of the much larger Orion Molecular Cloud Complex. Located around 1,500 light-years away, the Horsehead Nebula was first recorded in 1888. It's one of the most identifiable nebulae simply because of the shape of its swirling clouds of dark dust and gas, which really does bear an incredible resemblance to a horse's head. To the west of Orion's belt, you will see a V-shaped grouping of stars which represent the head of Taurus the bull, who in Greek mythology was changed by the god Zeus to carry Princess Europa off to Crete. The V is also part of a large open star cluster known as the Hyades. One of Taurus's eyes is the giant orange star called Aldebaran, or the Follower, which is located around 65 light-years away and has about 1.5 times the mass of the Sun. Aldebaran is thought to contain a number of Jupiter-sized planets. Aldebaran's already evolved off the main sequence, having exhausted its core hydrogen fuel supply. It follows the Pleiades, or Seven Sisters, a spectacular open star cluster to the northwest of the V. Located in the constellation Taurus, the Pleiades is one of the nearest and youngest open star clusters to Earth, located just 443 light-years away. There's a story in Greek mythology which tells us that Orion fell in love with the Seven Sisters and pursued them for a long time. Eventually, Zeus turned both Orion and the Pleiades into stars. Interestingly, a similar story is told in the Aboriginal Dreamtime culture of the Great Victoria Desert region near Aldea in outback South Australia. Orion's described as a young male hunter who chases but never catches the Pleiades, who are a group of 7 young women. In Orion's right hand is a club filled with magic fire and represented by the red giant star Betelgeuse. However, the Pleiades' older sister, represented by the Hyades star cluster, taunts Orion, standing in front of him. She defensively lifts her foot, which is the star Aldebaran, and is also full of fire magic. And this causes Orion great humiliation, putting out his fire and allowing the Seven Sisters to escape. Now, one of the interesting facts about this ancient Dreamtime story is that it accurately describes the variability of Betelgeuse, which brightens and fades over a 400-day period. The Pleiades' Seven Sisters story is remarkably similar to legends found in many other cultures around the world, and which haven't had any contact with each other for tens of thousands of years. The Pleiades' 7 brightest stars can be seen with the unaided eye, hence the Seven Sisters nickname. But this spectacular open star cluster actually consists of more than 100 stars. Now, if you follow Orion's belt to the east, it brings you to Sirius, one of the nearest and brightest stars in the sky. Located just 8.7 light-years away, Sirius is a binary star system with a spectral type A white star orbited by a white dwarf. It's the brightest star in the constellation Canis Major, the Great Dog. In Greek mythology, Sirius was the dog star and the canine companion of Orion the Hunter. To the ancient Egyptians, Sirius was known as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Later, Anubis was replaced by Osiris as lord of the underworld. Sirius also represented the god Isis, and ancient Egyptians initially based their calendar on the star's yearly motion across the sky. Now, if you look high in the southern sky in February, you'll see the star Canopus, a white supergiant located 313 light-years away, the second brightest star in the night sky after Sirius. In Greek mythology, Canopus was the helmsman of the Greek king Menelaus, and the brightest star in the constellation Carina, which represents the keel of the boat used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Puppis. Also in the southern skies this time of year, you'll see the large and small Magellanic Clouds, which are 2 dwarf galaxies orbiting our own galaxy, the Milky Way. The Magellanic Clouds were known to the Polynesians and Maori and served as important navigation markers. They're named in honour of the Portuguese navigator Ferdinand Magellan, who was the first European to sight them during the first circumnavigation of the Earth between 1519 and 1522. Magellan himself didn't complete the circumnavigation. He was killed in the Philippines during the Battle of Mactan. Right now, the Large Magellanic Cloud is located almost directly overhead and is about 163,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers have classified it as a disrupted barred spiral. It's around 14,000 light-years in diameter and contains about 10 billion times the mass of the Sun. Located slightly lower and to the west, you'll see the Small Magellanic Cloud, which is located around 200,000 light-years away. It's classified as an irregular dwarf galaxy, about 7,000 light-years wide, with about 7 billion times the mass of the Sun. Astronomers speculate that it too was once a barred spiral galaxy, but had become disrupted by the gravitational tidal perturbations of the Milky Way. Turning to the planets now, and Jupiter is in the north west of Aries. On February the 16th, the crescent moon will be to the right or north of Jupiter, so it'll be easy to spot. Right now, Saturn is low in the west in Aquarius at the start of the month and is about to disappear below the horizon. Turning to the morning stars, or more accurately the morning planets, and Mercury started the month off low in Sagittarius in the southeast, but is now moving into Capricorn. Venus is also in the east, moving from Sagittarius to Capricorn during the middle of the month. Venus, of course, is easy to see as the morning star, because it's the brightest object in the night sky other than the moon. And the red planet Mars is also making a morning appearance this time of year, moving east from Sagittarius to Capricorn during the middle of the month. And that is Skywatch for February. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog. You'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.